Hello and welcome for our video today. Today we are going to be continue discussing molecules and compounds. Today we are going to talk about interpreting or analyzing a molecular chemical formula. Now this will be very important when we shall be discussing more concept, where we shall be talking about calculation of molar mass, and also this analyzing correct analysis of a chemical formula would be helpful when you're balancing chemical equations. So this is a segment of chemistry which is very, very important. Actually, all chemists should be able to analyze formulas. Now here we have some formulas. We're going to see now how we analyze these formulas. These are just a few. We have many formulas, but this one should just give you an insight on how to analyze these formulas here. Now we have sulfuric acid here. This chemical formula has got now the type has got hydrogen atom, sulfur, and oxygen atom. Now, just after hydrogen, we have a 2 here. These 2 indicates that we have 2 atoms of hydrogen. Just after sulfur, we don't have anything, so it is just 1. And after oxygen, we have 4. So we have 4 atoms of oxygen. Now, if we can be able to see this one from another angle now, we are representing this a model for this molecule here, now indicating the individual atoms. You can see that we have 1, 2, 3, 4 oxygen, 1, 2 hydrogens, and 1 sulfur. Now you can see these numbers here. We have a 1 here for hydrogen and the number here which is 16 for oxygen, and the other 2. These numbers are very, very important when you are calculating the molar mass for these molecules. We are going to see that one in a while, and also we are going to continue seeing this one as we do our videos on mole concept. Now we have this other molecule here. This we call it a nitric acid. This nitric acid, you can see we have different types of atoms: hydrogen, nitrogen, and oxygen. Just after hydrogen, we don't have any number, so it's just 1 atom of hydrogen. And just after nitrogen, we don't have any number, so it's just 1. And after oxygen, we have 3. Now it means that we have 3 atoms of oxygen for this molecule. As you can see from this model here, this model for nitric acid, we have 1 hydrogen and 1, 2, 3 oxygen, and then we have nitrogen, 1 nitrogen. That is analysis for that molecule. Let us look at sodium carbonate. This is a formula for sodium carbonate. It has got 3 types of atoms: sodium, carbon, and oxygen. Now just after sodium, we have a 2, meaning that we have 2 atoms of sodium. Just after carbon, we don't have any number, so it is just 1 carbon atom. And after oxygen, we have a 3, so we have 3 atoms of oxygen. From our model here, you can see that we have 1, 2 sodium atoms, and then we have 1, 2, 3 oxygen atoms and 1 carbon. So that is analysis for sodium carbonate. That's chemical formula. Then we have a magnesium here. Now you can see this looks quite different because of these brackets here. Now we have 3 types of atoms in this one. We have magnesium, we have nitrogen, and oxygen. Just after magnesium, we don't have any number, so that means we have 1 magnesium atom. From this model, you can see it more clearly. We just have 1. Now here, this nitrate has got brackets surrounding it and 2. It means that we have 2 of these nitrates here. Or you multiply everything which is inside here by 2. So if you multiply nitrogen, 1 nitrogen by 2, we get 2, as you can see from our model here. Then we have 3 oxygen times 2 is 6. So we have 1, 2, 3, 4, 5, 6 oxygen atoms. In short, it means, this bracket means that we have 2 nitrate ions for this molecule. Remember, this is a nitrate ion, it's a radical. We talked about polyatomic ions, so we have 2. So in case we have 1 magnesium and 2 nitrate ions, meaning that we have 6 oxygen and 2 nitrogen. Let us look at another molecule here. This is a potassium hydrogen carbonate. Remember, hydrogen carbonate is a polyatomic ion. Now we have 4 different types of atoms: potassium, hydrogen, carbon, and oxygen. Now we don't have any number after potassium, so it means we have 1. Look at our model here. Then we don't have any number after hydrogen, so we have only 1 hydrogen, as you can see. We don't have any number after carbon, so we only have 1 carbon. And we have a 3 after oxygen, meaning that we have 3 oxygen atoms for that molecule, and that is analysis for that molecule. Now our last molecule here is sodium nitrate. We have 1, 2, 3 types of atoms in this molecule. We have a sodium, we have a nitrogen, and we have an oxygen. We have no number after oxygen, meaning you have only one atom of oxygen. We don't have any number after nitrogen, meaning we have only one nitrogen atom. And 3 after oxygen, meaning we have a 3 atoms of oxygen for that molecule. Now, let us briefly look at these numbers. Now, for this sodium, you see we have a number here which is 23. This is called a mass number. And if you look at our periodic table here, this is oxygen. And if you look at the nucleus here, we have protons which are red and neutrons which are green. The total number of this one is 23. Now this is what gives us the mass number. If you look at nitrogen, which is in group number 5, this red gives the proton 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This number here is what gives us now that number that you are seeing here, which is 14 for nitrogen. Now if you look at oxygen, this oxygen is in group number 6. The total number of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That 16 gives us now the mass number for oxygen. Now, if you add now these numbers, and remember we have, because we have 1, 2, 3 oxygen atoms, you have to multiply 16 times 3. The total will give us the mass number for that molecule or that compound. Now, remember we have mass number for individual atoms. Now, if you do an addition, the total number that you get now will give us the mass number for that molecule. We shall be looking this one. We shall be talking about the mole. We shall be calculating now the molar mass and so on and so forth. But this is very important: how to analyze the chemical formula and how to calculate now these mass numbers. Thank you very much for watching this video. We are going to meet in the next video where we shall continue looking at these molecules as we move on to tackle now the mole concept. Now these are very good. These are very good bases for the mole concept as we move on. Remember to subscribe, hit that notification bell, and we meet in